Hello and welcome to the second video in this three-part series where we're looking at building a ScrAPI. So a ScrAPI is something that goes to a web page, scrapes all of the HTML and then transforms that into data that we can actually use, and then exposes that through an API. So in this case, we're going to be exposing a GraphQL API using Apollo server. So I recommend if you haven't watched the previous video, definitely go back and check that out. It goes through how we did the initial stage of that scraping. To give you a quick overview, where we got up to in the last video was we built this function, so this scrape function. Now that's an async function, so here it is. So that's an async function that basically fetches the HTML data from this page on the left. So this is a collection of skaters from Tony Hawk's Pro Skater. It fetches that data. It then transforms that HTML into JSON. So transforms all the different bits, pulls out the names, stances, stats, all of those different bits, and then returns a nice JSON version of all of that data for us to consume somewhere else. So the first thing I'm going to do here is I'm going to firstly rename our function. So at the moment it's just called scrape, but I'm going to rename it get skaters. And then at the bottom of this file, rather than actually calling the function, I'm going to expose the function so a different file can import it and then run that function. So I'm going to say modules.export. And I'm going to say that is equal to an object, and I'm going to expose get skaters from this file. So this means other files can now import this function and then use it. The next thing I'm going to do is I'm going to organize our folder structure a little bit. I'm going to create a new folder called utils, and in there I'm going to move this index.js file. I'm then also going to rename that scrape, just so we know that's our scrape utils or our helper for scraping. And then I'm going to create in the root directory another index.js file. So this is going to be our actual application, our actual GraphQL API. So we can just test firstly that we can actually run that function. So let's say const get, we need to destructure it. So get skaters equals require, and then a path to that actual file. So this is going to be ./utils/scrape. So then we're going to pull out the get skaters function. Now that function is asynchronous, so it basically returns a promise, and then when that promise resolves, we get back those skaters. So I'm just going to call get skaters, and then when I actually get my skaters back from that function, I just want to console log out those skaters. So this is saying call the function, and then when we get back the skaters, console log out those skaters. And now my package.json should still work because my start script is pointing at node index.js, so that should run this new file. So if I run npm start, we see an error. Modules is not defined. Sorry, module.exports. Right, module.exports, not modules.export. I always get those around the wrong way. Cool. So we get back where we got up to in the last video, where we're getting back that array of those different JSON objects that represent our skaters. Awesome. So that's working correctly. So we can pull in get skaters and we can run it. So now what we want to do is we want to introduce Apollo server. So Apollo server is a GraphQL library that allows us to build a GraphQL API and allow GraphQL clients to consume that. So it's a little bit different from its alternative, which is a REST API. So you may be familiar with a REST API where you make like a GET request /users, and then that is going to return you a big array of all the different users. So like their name, whatever. So in our case, this might be /skaters. And then that is going to return us an array of objects, and the first object has the name Tony Hawk, and so on. Yeah, so this is sort of it's still a very valid way to build APIs. It's not deprecated by any sense, but GraphQL is a new way that we can that our clients can specify the exact data that they actually need and request that from the GraphQL server. So in this case, if we request skaters, we're going to get back all the skaters, and we're going to get back every single field for every one of those skaters, no matter what, because we're just exposing one endpoint that says, if you make a GET request to /skaters, I'm just going to give you back all of this stuff. And if you make a request to get skater and pass me a name or whatever, I'm going to give you back just that particular skater, but I'm still going to give you back every field. So then GraphQL decided to reimagine this slightly. So you can create a query, and in that query you could say, well, I want to get all of the skaters, but I only care about their name and stance. So the client itself defines the kind of structure that it needs back. So it defines that it's making a query for all the skaters, but it only cares about getting back the name and stance. So the benefit here is that the server goes and does its work and finds the skaters and does whatever it needs to do. But then when you're sending that information back, you're sending back a lot less information. Rather than sending back name, stance, type, all of those stats, everything that we get back about our skaters, we can just send back the particular bits that our client actually cares about. Okay, cool. So hopefully that's a little bit of a quick overview of what we're trying to achieve here. But yeah, let's get into using this Apollo server package, and then hopefully it will make a little bit more sense. So I'm going to get rid of that. I'm going to get rid of this get skaters. We'll still import it in because we'll need it eventually. But if we have a look at this getting started guide, it says that we need to install Apollo server and GraphQL. So let's do that. And then we're going to import those. So we're going to import Apollo server, and we're going to import GQL, which stands for GraphQL. And we're going to get those from the GraphQL, Apollo server. Cool. And that's finished running, so that should be all good. So there are two parts to a GraphQL schema or a GraphQL API. The first thing you have is type definitions. So these are, we're going to declare a type for every one of our fields. So every one of our skaters, we're going to declare that their name is of type string, and their stance is of type string, and their stats for Ollie is of type integer. So we provide a schema to say these are the different types that each of our GraphQL things are. We can then declare a collection of resolvers. So resolvers are just the functions that are run to resolve a particular value. So when the client requests one particular skater, we need to have a resolver to go and work out who that skater is and then return the bits that we actually need. So let's declare those two bits first. So we have const type defs, and that's going to be equal to the GQL tags, and then we're going to use backticks. So anything in here, anytime we declare a new type, it needs to be inside this type defs function call to GQL. So I guess to follow the example that we have here on the left, let's create a type of query. So this is going to be a query that our consumers or our clients can actually request. So it's going to be hello, and that is going to return a string. So this is the query that you would call, and then you're going to get back something of type string. So then we need to declare a resolver to actually handle that request. So we're going to say resolvers is equal to this object, and inside that object we're going to have a query, and inside our query object we're going to have that hello thing. So this type needs to match this resolver. So or for the query anyway. So we have two different types of queries or requests that can happen. We have queries which are when we're trying to get information, so anytime we're trying to read anything, and then we have mutations, which are used for anytime we want to write new information. We won't cover mutations in this example. I might do a different video about that in the future. For now, we're just going to cover queries. So this is just about reading data. So we're making requests to our API to get those Tony Hawk skaters. Cool. So when we request hello, we are going to run a function. And in this case, we're just going to make it an inline function to demonstrate what's going on here. We're going to say hello world. So anytime someone tries to query hello, we're going to return them the string hello world. If we scroll down, we can just copy and paste this part, but I'll step through what it's doing. So we're declaring a new server. So this is using Apollo server. It's creating a new instance of a server, and we're just passing in those two objects that we declared. So we declared type defs and we declared our resolvers. I'm getting a little bit of red here, so I just need to work out what's going on. Query that's that. Okay, let's just see if it has a, oh, sorry, I'm missing a colon here. Cool. Okay, so again, we have our type defs, which is where we declare all our different types, and then we have our resolvers, which are the functions to go and actually get those values. So we then create a new Apollo server, passing in the type defs and the resolvers, and then we set up a new server listening over a particular port, and then we're just console logging out that the server is ready at URL. So if I now run this, so if I say npm start, we're going to get this server that's running at port 4000. So if I copy that URL, we get this nice little graphical thing here. Ignore what's pre-filled here. You'll probably have some comments and things. So if we, if you get rid of what is there and you start typing query, it's going to start auto suggesting what you might want to, what you might be requesting. So this thing happens automatically. So when we go to localhost 4000, it's automatically connecting to this server. And part of the implementation of GraphQL is that if you make a request to that server, it will give you back this graphical view, which is probably the coolest thing about GraphQL, and probably the reason that adoption has been massively successful, is that they essentially give you the tools bundled up with the actual package itself to be able to do some really, really powerful things and be able to interact with the GraphQL API. So as I was saying, it does auto-suggest for you, which is awesome. So I am making a query, and then the other thing that you can do is anytime you're not sure what you might need to write. So here, if I do query, and then, well, I guess in this case, I need my first rounded brackets, curly brackets. I might zoom in as well. You probably can't see much. Okay. So this is what it looks like. So we have our query, but now I don't know what queries are available. I don't know that this specifically has a query called hello, which I can request and get a string back. So if I have my cursor highlighted somewhere and press Control Space, it's going to give me suggestions of things that I actually can query. This is, yeah, just something that blew my mind when I started using GraphQL. It's something that makes like building up a GraphQL API just amazing. So this is all populated based on the schema. So you'll see here that we have this schema, which is kind of not a very nice looking thing, but we also have docs. So if you click docs, you'll see here that it has a list of the different queries that we've declared. So here we've declared a hello query, which gives you a string back. And if I click into that, it tells us what a string is. So string is a Scala type that represents textual data, blah, 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 blah. So we can actually see the documentation in line inside this tool that we're using to query our server. So it's amazing that we are able to learn about our server while actually using it, which is amazing. Sorry, I get so excited about it. I gush about GraphQL or GraphiQL itself, because this tool is just like awesome. So we want to make a query for hello. So now if we run this, you'll see that we get back this data object, which has a string hello, has a key hello, which is giving us back the text hello world. Cool. So our function is working, right? We're calling hello, or this resolver is working. We're calling hello. It's giving us back hello world. So let's make this a little bit more complicated, and let's introduce the idea of skaters. So we're going to get rid of hello, but we'll start from the top. So we're going to replace this hello query with a query for skaters. And now the type of this, obviously this is a big array of objects, so we don't have a built-in type like string or int or anything like that. So what we're going to say is this is going to give us back an array of type skater. We then need to tell GraphQL what is a skater. So then we need to declare a new type for skater. And we need to tell GraphQL what actually exists in a skater. So for now, let's just stick with some simple bits. So let's say that we have a name, which is a string, and a stance, which is a string. So again, we have created a type for query, which has skaters as one of the available queries that we can call. We're then declaring that this is giving us back an array of skater. And we are declaring a new type for skater, which just has a name, which is a string, and a stance, which is a string. So we need a resolver to actually go and get that data for us. So again, our query, the name of our query needs to match our type for that query. So we have skaters, and then this is going to call a function and then give us back the return value. But we've already declared this get skaters function. And as we saw before, if we call get skaters, when that resolves, we get back that big array of our skaters. So why don't we declare this, because we're going to have to wait for that, because this is an asynchronous function, we're going to have to wait for it to resolve. So let's say our resolver is an async arrow function, and that is going to await the skaters that we get back from calling get skaters. So if we save this and check our console to make sure that we don't have any big horrible errors, actually we're going to have to quit our server and rerun it. So if we quit by doing Control-C and then run npm start again. Cool. Our server is running again. And if we come across here and refresh, yep, it's going to refresh that. We get rid of what's there. And if we do Control space again, we can see that query is one of our options. So we're going to do query, and then we're going to do our brackets, and we're going to go Control space again, and we see skaters now. So now we can actually query for skaters. And if we do another angled bracket around or inside skaters, we can declare what we actually want to get back. So here we want to get back a name, and we want to get back a stance. So now if we run this query, this is going to take a little bit of time, but what it's actually doing is it's calling that function, which is going off to the web page and scraping all those HTML elements, and then it's transforming all of that HTML into JSON and then returning us what we're actually asking for. So here we see Tony Hawk, Goofy, Bob Burnquist, regular, blah, 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 blah. So we're getting back all of those results, which is awesome. But the cool thing about this is if we didn't actually care about the stance, if we just wanted to know the name of each of our skaters, we could just make a query for their name. And then when we run that query, it's not actually going to return a stand. So it's not going to waste those extra bits of data sending all of that back when we're not actually going to use it in the client. We don't actually care about those different bits. So now we can just go through and fill out the rest of our type for Skater. So I'm going to copy image and type from here. It doesn't matter like what order it's in. It's okay if it's in a different order to our other object. Also, it might look a little bit weird that we don't have commas at the end here. So that's something that's specific to GraphQL. If you have a comma, it actually will fail building the server. So now we've got a name, a stance, an image, and a type. So I'm going to save this. And again, I'm going to have to restart my server. So restarting my server isn't, it's a bit annoying to have to do that every single time we make a change. So I'm going to install a handy little package called nodemon or nodemon. And I'm going to install this as a dev dependency. So -D means that it will be a dev dependency rather than a project dependency. While that's installing, I'm just going to go into my package.json and just change this start script to, rather than using node, I'm going to say use, actually I might just wait until this has finished. Cool, now that it's installed that dev dependency, rather than our start script just calling node, I'm going to call nodemon and give it index.js. So yeah, really all we add is mon to the end of this. And then what that's going to do is every single time we make a change, it's going to restart our server. If I can spell things correctly. So you see this is now sitting there running our server. So our server is listening at port 4000. But if I was to go in and actually change a word somewhere that's not going to break, so maybe I'll just remove the R from ready. If we go back to our terminal, you'll see that the server eddy at localhost 4000. So it's actually stopped our server and restarted it just by us making a change and clicking save or doing Command S. So that's going to make our development of this a little bit faster. So now we can refresh our localhost 4000 and see whether we have these extra types. So again, we want to make a query for skaters, and then on each of our skaters we have a name, we have a stance, we have an image, and we have a type. So let's just make sure that we're actually getting that data. Stance, image, and type. Cool. And you see that we get back each of our skaters with their image for their little logo and what type they are, as well as their, all of that. So now we just need to build up our stats. Now, the reason I left that out is because it's going to be a little bit more complicated because, again, our stats aren't just a type. So we can't say our stats are just of type string or anything like that. Our stats need to be of a particular, like it's an object, right? It's an object with all those different key value pairs. So our stats are going to be of type stat. Actually, let's say of type stat. And then we need to create a type for that stat. Again, I'm not going to write each one out. Oh, actually, I can't copy and paste it. No. Looks like I am going to write each one of them out. Or I guess I'll just open up this and I will write air. Actually, this might take a little bit of time. So just to speed things up, I'm just going to get rid of this for now. I'm going to, rather than just awaiting our skaters, I'm going to give this function a body, and I'm going to say const skaters equals await get skaters, and then I'm going to console log out my skaters, and then I'm going to return my skaters. This is the lazy way of being able to copy and paste all of our stats. So if I make a request again, it will go and run this function, which should hopefully dump out here all of our stats. So I'm going to copy one of those, and then I'm just going to undo our example back to where it was. So we've got our stats of type stat, and we've got our type for stat, and then I'm going to dump in all those different stats. Okay, I'm then going to select all of those and give them the type of int, and this last one as well. Because each one of these is going to be a number, right? So air is going to be an integer, landing, hang time, switch, ollie, rail balance, speed, lip, balance, and spin and manuals are all going to be of type integer. And so now our stats object is going to be of type stat. So our stats is going to be this kind of object that's going to have an air, landing, blah, 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 blah. Cool. And that should be all we need to change. If I now save our application again, and I refresh here on the left. If I open up the docs now, we should see that skaters returns a type of skater, and that has on it stats. And I can click into stat and look at what that actually looks like. So I can see that the docs have been updated because our schema has been updated with those new types. So now I want to make a query for all of our skaters, but I only actually care about their name and what their ollie is. So now if I make that request, it's only going to return me their name and their stats, which is an object, and inside that, their actual ollie. So I can declare, even in those kinds of deep objects, like I can say, well, inside the stats object, I only actually care about that one part. So just give me back that one part. It's going to go work that out and send it back, but it's not going to send back a whole, like every single skater with every single name, every single stance, every single everything. It's only going to give us back the bits that we actually care about. So that's awesome. But now we have these one query to get all of our skaters, but what if we wanted to be able to just get one particular skater? So the first thing we'd need to do is extend our query type. So we'd need to add to our query type a skater. And now this skater, we're going to have to be able to pass some kind of value to this skater. So we're going to pass an input, and that input is going to be of type, let's say skater name. So again, we're going to have to declare that type. So type skater name is going to be an object with a name that's going to be of type string. And we can use this exclamation mark to say this is a required field. So you're not going to be able to run this function unless you provide me a name. So we have to give a name. And then this query is going to return us the type skater. So rather than an array of skaters, we're just going to give it one singular skater. Now the benefit of this is we don't need to go and create a single skater because we already did that when we created the array of skaters. So we already know what a skater is. So even though we're only requesting one particular skater, we can still benefit from all of that typing that we've done here, where we can just select the name and the stats for spin or something like that. So super, super powerful. So now that we've created those types, we now just need to create a resolver. So what's the function that needs to run to actually do this work? So we're going to have a skater, and that's going to be an async function. That's going to take in some stuff, and then we're going to await a call to get skaters, passing in a name. So where does this name come from? If we have a look here, we've got, this is the callback that GraphQL will run. And so it's actually going to pass a couple of values in, or a couple of parameters in for us. The first one we don't care about, it's context, which again, we can look into this in a later example. But the second parameter is our variables. So that's what we've specified here, any variables that we're passing to that query. So we can destructure input off this, and we could even go one step further and actually destructure name. So now when we call scatter, we're going to pull the input off the variables and then the name of the input, and we're going to pass that along to get scatter, so the individual scatter, which is a function we're going to have to write, and we pass in a name. So let's just quickly go and write that function. So in scrape.js, we're going to, underneath our get skaters, we're going to create a new function called get skater. Again, that's going to be an async function. It's going to take in a name, and then maybe we'll just console log out that name so that we can confirm everything's working up until this point. And then we're just going to return null. So this function requires us, or the GraphQL declaration requires us to return a scatter. But because that scatter is not mandatory, like we may not actually find a scatter that has that name. So if we return null, it's just going to give us null back in our request. So this is just an easy way that we can check that this part is working and just return nothing. So we also need to export this from this function. So we're going to add get skater to our module.exports, and then inside our index file, we are going to import get skater. Cool, so that should wire all of this up to work properly. So we have a query for skater, and if we pass it a name, it's going to go off and call get skater and pass in the name. It's going to wait for that value to come back, and then it's going to return it from that resolver. So if we come across here, and I'm just going to open a new tab to keep this a little bit cleaner. If I say query, we don't have skater here, so I'm just going to refresh. Oh, unable to connect. Okay, we may have made a blunder. Yes, so up here where I've declared a type for skater name, this isn't actually correct. Anytime you're typing an input, rather than using the type keyword, you need to use the input keyword. So this is the same as type, but you're declaring a particular type, a specific type for an input. Cool, so that should hopefully fix that issue. Looks like it's running. If we load this and open up a new tab, if I say I would like to query for a skater, and then you'll see here it pops up with this helpful hint. So it's saying, hey, you're asking for a skater, but it must have a collection of subfields. So did you mean skater and then some kind of body of something? So I give it the angle brackets, and then I press Command Space again, and I get all these different options. So because it knows that we're going to give back a skater, we can say, well, I want the name, and I want the stance, and I want the type for this skater. And now if I try to run this, we're going to get cannot destructure name of property name of undefined. So the problem here is that we're calling skater, but we're not actually providing it an input. So maybe we'll say here that skater name is actually required, so put an exclamation mark after that, and then inside that skater name, this name is required. So the exclamation mark means you need to have this, because then if we run this, it's actually going to give us a more helpful error message. It's going to say field skater argument input of type skater name is required but was not provided. So what it's saying here is you need to give me a name. So if I put brackets here, it's already suggesting, hey, you probably want input. And then again, if I try and run this, it's going to say, it doesn't want to run, but it's going to tell me that I've provided input, but the type skater name requires a name because we've put this exclamation mark here. So we need to give it a name. So we can say, okay, a name, which is of type string, is going to be Tony Hawk. So now when I run this, I get scatter null because we're returning null explicitly, but you'll see here that it's actually printed out the name Tony Hawk. So everything has propagated down to our function correctly, and our function is running because it's printing out the name, but here we're just returning null. So what we're going to do, just to speed up the development in this video, we're just going to use that getScaters function. So we're going to say const skaters equals getScaters. Because this is an async function, we need to await that value to come back. And then once we have those skaters, we want to say our actual skater that we're looking for is going to be inside that array. So I'm going to say skaters.find, and then this allows us to iterate over each skater and pass in a condition that if it's met, then it will return that actual object. So for each, I'm just going to use s because I've already declared skater here, but skaters.find, so it's going to pass in each skater, and then I'm going to say if the skaters.name is equal to the name that I've passed into this function, then I've found a skater. I found the skater that I'm looking for. I found Tony Hawk, and so then he is going to be assigned to skater, and then I want to return that skater. So now, if I rerun our query for that particular skater, you'll see I actually get back Tony Hawk, Goofy, Vert. And if I was to change this to, I don't know that I can spell Bob Burnquist, but let's give it a go. Awesome, I got it right. So if I specify that I want Bob Burnquist, then I can get Bob's information. But there's a little bit of, well, it's not a problem, but if I don't actually know that skater's full name, then I'm not really going to be able to find them, right? So Tony Hawk is easy, and I guess that's about it. But if I wanted to just be able to search for Bob, for example, and get that back, I'm going to need to modify my getScater a little bit. So this is still going to be the same GraphQL stuff. It's going to be the same query. It's going to be the same resolver. But inside my function, when I get back all of those skaters, I want to find, I can make this a little bit of a looser condition. So I can say, firstly, I might want to check if, to lowercase is equal to name dot to lowercase. So this makes it a little bit looser in that the capitalization doesn't matter anymore. So if I was looking for Tony Hawk, this would match and give me back Tony Hawk. But if I was looking for Tony Hawk with a lowercase h now, I would also get back Tony Hawk. So this is going to match even though it's not the same case. So that, that's a little bit nicer. The next thing that I might want to add is like, if I'm looking for Tony Ha, I want it to still return Tony Hawk. So I can chain on one more thing to here where I can say if s.name.toLowercase.includes name.toLowercase. So what this is doing is we're getting the full lowercase version of the skater's name, and then we're checking is anywhere in that skater's name, does it include the name that we're actually looking for in lowercase? So now if I send this query, I should get back Tony Hawk. Awesome. Okay, that worked. Cool. So that's just an example of how like our resolvers are just functions. They're just functions that are running. We can add as much JavaScript as we want to those resolvers. It's just a function. It's just a JavaScript function. The only bit that really matters to GraphQL are those two parts that I mentioned at the start. So type defs. So we need to declare every single type for everything in everything we want to expose from our API. And we need to declare resolvers. So we need to tell it which function it needs to call to be able to get this data back. But now we have this really super flexible API where if we want all of the information about one of our, if we want like all of the stats for all of our skaters, we can make a request for all skaters and grab their names and all of their stats. And then we can see all of their stats there. If we only care about a particular skater's name, stance, and type, we can just make a request for that particular skater. So it's a really powerful way for our clients or our consumers to declare what kind of data they actually care about, because there's no point getting all of this data and then sending it all across the wire when they're only actually using the name. Like they're just displaying, they're iterating over that array and displaying the name for each skater. That's a big waste. So GraphQL allows the client to specify exactly what it needs to be able to satisfy what it needs to do. Cool. So hopefully I've sold you on GraphQL, and if you were already sold on GraphQL, hopefully I've given you a little bit of an understanding as to how to actually write queries and how to type things in GraphQL. This is very similar to the example that exists on the npm page for Apollo server. So I recommend that you go check out the docs as well. If you actually want to implement this and do anything fun, the Apollo server docs are awesome. And when we get into the Apollo client side of things, the docs are super, super helpful. Cool, so that's everything I wanted to go through in this video. Again, if you haven't watched the video before this, or if you want to watch the next video, I recommend doing that. If you want to check out any code examples, if you go to github.com/monoglot, I have all of the examples on GitHub. And if you want to actually look at the blog articles for any of these videos and be able to really conveniently like copy a chunk of code, then head over to monoglot.dev, and there will be a list of things that you can check out. Awesome. Make sure to like and subscribe and do all of the YouTube things. I never know how to sign these off like a true YouTube star. So yeah, just watch the next video. Bye.